Hello world, here's Jorge, and let's continue learning about object detection in PyTorch. Last time we actually analyzed what kind of information was stored in this file, this science data file, which remember we had to deserialize. Okay. So today the main goal is actually to define a function that is able to filter the data that is stored in this folder, this file, to basically fit our needs. Okay. But let's get started. So let's now call this section understanding detection. Okay. Fantastic. So now let's talk about actually the data set, because you might wonder, okay, where is this data coming from? So it's actually coming from these say website, where basically it's a German association, German traffic recognition benchmark, where actually we're using the German. So actually get a closer look. So it's the German traffic sign detection benchmark. There's a there's a GTSDB. That's the one that we're interested in. So great. And what we need to understand is that each sign occurrence in this data set has ground truth associated to it. What do I mean by that? So essentially there's a specific bounding box and a sign label associated to each image. Okay, to each sign, better say. Okay. All right. So now what we can do is start say defining this function. Okay, so define a function that filters our data. Okay, so let's put in here. Let's mark that down. So what we want to do now is to define this function. This function is able to filter our data, and we're going to call it a load data. So this load data function is going to do the following. Needs to be able to do the following. Okay, needs to first of all use this science data path. Okay, and basically deserialize it. So it's going to need to use this torch dot load. Okay, to deserialize our data. So first step is going to let's put instead of this like that. Yeah, better. So first step is going to be loading. So loading. This function is going to be loading this data set. This data set actually from the file. This file called science data.pth. I'm mistaken, it's like that. Correct. Loads the data set from the file and and deserializes it. Okay, using this torch, torch dot load function. Well, it's actually a class. Okay. Fantastic. So that's the first step. And second step, we're going to write an algorithm that is able to filter. So filters the data set. We'll see all the details later. So then that's second step. The third step, we're going to return. So this function is to return these filtered data set as a dictionary. That we're gonna call I am. Wait a second. Yeah, I am DB. Okay. Great. Yeah, fantastic. So now let's go step by step with this function. So let's get started. So let's define. Let's define this. So load data, and what are we going to take as an argument for this function? So we're gonna need to specify, okay, to this function what kind of filtering do we want to apply, okay, and this filter, yeah, is going to be actually a class. Yeah, so we're going to specify a specific class that we want to get from the overall data set, and this function is going to get it for us. Okay, that's clear. What else? So now let's understand what kind of classes can we have. Okay, and to understand that, we actually need to explore the actual dataset website. So, and remember, our dataset is this GTSDB. So let's go here and let's have a look at this website, because there should be information about. Okay, yeah, this looks like that. So you see, we have these three classes. And actually these are the classes that we're going to be interested in. And not only that, not only we're given the possible classes, but we also given the class labels, okay, so that we understand how are they labeled. Yeah, so with that information, now we can actually construct our function. So we need to actually specify this information. So, well, but before that, we need to load the data. Okay, so remember, that's the first step. So first step, load the data set and serialize it. Okay, so for that we are going to need to use this torch.load. Okay, so we're going to remember this is going to be a dictionary as we found out in the last video. So let's call it IMDb, and is going to return, basically it's going to say, okay, so torch.load, and remember, here we need to specify the path. So the path is going to be, remember, the path is data and science data. Okay, so data and science data dot pth. Okay, like that we already have our data loaded and deserialized. So now we can start exploring it. So now we need to include a series of if and else statements. Okay, so we're gonna say, okay, if the meta class, so if the class that the user chose to get information, from, it's actually, say, prohibitory, so if this class is equal to let's see if I can spell it correctly, pytorch. I think, yeah, that should be correct. Prohibitory. Okay, and this is a string, right? If that is equal to meta class, so if that is the case, then we are going to say, okay, so this meta class is going to have the following meta labels, so the following labels associated to that class, yeah, which, remember, we can extract from the website. So labels, and this is going to be actually, the thing is here, prohibitory, and the prohibitory is this thing. Okay, let's copy paste that. Fantastic. So there we have it. Okay, that's one possibility, but another possibility, elif, is if the actual class is equal to danger. Okay, imagine is equal to danger. If that's the case, we are gonna do the analogous procedure. So it's going to be, okay, so in this case the labels are going to be danger, these labels. Okay. So that, okay, so these are the labels for danger. What else? Now there's one more missing. So there's this mandatory. So actually what we can do is just copy paste this. Okay, so let's tap that to the left. Okay, and stop this here. Great. So this is going to be actually is a prohibitory, danger, and mandatory. And the mandatory, we can see here, is this. So as you can see, pretty straightforward for now. It's just first actually assigning the right labels to the specified class. That's all we're doing for now. Okay, so but what happens, because we also want to include the option for the user to actually get them all, okay, not just get one specific class, but say he wants all the information, right? So in that case, we just create all option. So let's just say elif meta class if it's all, if the user specifies all the classes. In that case, we're just gonna have to specify that the labels that are going to be available are going to be all of them, right? Are going to be all of them. So to do that, we just can say, okay, so yeah, there are, yeah, so we can just specify the number of labels that we have. That should be yeah, 42, I think, so range 43 because we start from 0. Okay, yeah, that should be it. So 43. All right, so now once we have specified that, we can start with the actual loop, the for loop, because what we want to do is to actually go through all the top level keys. So remember that last video we saw that we had two top level keys, we had train and we had val. So now all we want to do is to loop through those. So we're gonna have for subset, and we're gonna loop through these actually these two top level keys, which are train and val. Okay, and with that we're gonna do the following. So we're gonna actually think about yeah, how can we organize this? Yeah, so remember, what we want to do is to use the labels, use the labels, and then select the labels, and actually from those selected labels we're going to use those selected labels to filter our data. So so what we can do, well, first of all, I think I forgot the option of what happens if the say a user doesn't specify neither of these four, right? If the user doesn't specify neither of all mandatory, danger, and prohibitory, so we need to include that as well. And so we're gonna raise an error. So we can say else, and we can do rise and value error. Raise and value error, and we're gonna have here. We're gonna print out if that's the case. So the value of the meta class that you specify is not, or better say, because what we are specifying here are labels. So the value of the meta label is not available, say. Okay. Great. So that's it. But now let's go to the main point. So let's go to the actual loop. And what do we want to do? So first of all, we're going to collect all the labels. Okay, we're going to collect all the labels. Let me first write down and then explain why we're doing this. So labels. And we're going to actually write a list comprehension. So let's just say X, where basically this X is there's going to be elements, okay, elements of the box labels. So these are going to be elements, so they're going to be class labels, okay, for X in these basically labels. And remember from last video where we explored each subclass, let's go to the results. So if you remember, from the images we got paths, from the boxes we got a bunch of coordinates per boxes, so for the vector per box. For box images, again, we got paths, image paths. And look, for box labels, we actually got the labels. So we need to loop through these because it's where the labels are contained. Okay, but in this case, we're not gonna explicitly specify train. That's why we're looping, right? We're looping through both train and val. So instead of train, we're just gonna specify this subset. Okay, so let's just copy paste this. So this is going to be just data, and it's going to be subset here instead. Subset, and these box labels. And right now these X, these X, remember this is a tensor. Okay, so if we get, let's get the first, right? If you get the first, okay, you see it's a tensor. It's a tensor and it's not an integer. So we'd rather work with labels as integers within the loop, right? So to do that, we just need to say, okay, x dot item. Okay, x dot item is what's going to give us the integer instead of a tensor. Great. So now let's understand, why are we storing all the labels? Okay, why? Because remember, Depending on the option that the user selected, okay, we're gonna get say a list of classes, so a list of class labels. Okay, so this is going to allow us to filter our data. The class labels are the information that we're going to leverage to filter our data. That is why we first need to get all the labels, okay, all the class labels, to then make use of them for the filtering. Okay, now that we understand why we are storing the labels, let's now establish the criteria to select, to filter. Okay, and how are we going to do that? So to do that, we are going to create another list where we're going to store certain elements. Okay, so let me first write it down and then explain. So we're gonna have a list called select. Okay, so and in this list, what we're going to actually collect is all the indices corresponding to the elements within the list. Okay, so we're going to have a list of labels, and each element within that list is going to be associated to an index. So we want to store those indices that are associated to those labels. We'll understand why next. So let's store those indices, and to do that we create another list comprehension. Okay, so we're going to say, okay, I want to store all these indices, and to do that I'm going to look through these labels. Okay, I want to store the indices of the elements of the integers that are stored in the labels list. Okay, so we're going to say, okay, and we're going to have the elements of the list, of the labels list, and we're going to say for ix in, and here, well, remember, to actually keep track of both the elements and the index of a list, we need to use what's known in Python as enumerate. Okay, so enumerate to keep track of both the index and the element and the integer in the list. Okay, so enumerate. And this enumerate, and of course we're going to look through labels. Okay, so but if I leave it like that, I'm going to get all the say indices within the labels, but that's not what we want. Okay, we just want the indices corresponding to the labels that are actually present in the say list, okay, of labels. All right, and I know it's a bit confusing, something like that, but let me actually say give an example later. Okay, so we're gonna say, okay, if the following condition is met, so if the element within the list is in meta labels, okay, and these meta labels, okay, remember, it is actually the list of labels that corresponds to the chosen class by the user. So that is why we're just going to store, okay, this is basically store the following. So it's going to store the indices, okay, the indices that correspond to the elements of the labels list that actually are present in the class label list that is associated to the say main or the chosen class, okay, type. All right, so that is going to filter it. And now we're just going to use these say select these actual indices. We're going to use them to filter our data. So we're going to have let's start with the boxes. Okay, let's start with filtering the boxes. So yeah, let's put here filter boxes. filter boxes. All right, so we're gonna have IMBD. Yeah, it was like I think it was IMDB, yes. And we're gonna have the subset, and we're gonna have boxes. Okay, boxes, and we're gonna have this. Essentially, yeah, this is going to be filtered, because remember, how did boxes look like? So remember, boxes, yeah, let's just put it down. So let's just do it again. So remember, with boxes, if I have, just print the first. Oops. Why not? Yeah, because of course above I put it as data, not IMDB. DB is within the within the function, so it's like that. Oops, no. Yeah, of course, because it's not subset. Yeah, this is what happens when you copy paste too much. No, you don't have to copy too much. Okay. So you have train and boxes. So you see, you have a 4D vector. Yeah, you have a 4D vector, and what we want to do is to say, yeah, let's say we have a bunch of them, right? So we have 5. Yeah. Okay, so we just want to keep the 4D vectors of the boxes that are present within the class that we chose. Okay, so to do that, we just need to select that's why we are storing the indices, the specific indices corresponding to that, to the class labels that by themselves correspond to the main class. Because what we're going to do is to say, okay, now we want to say filter in the following way. We want to just select. We're just going to select, say, the first vector. Say that the first vector belongs to the class that we chose. Okay, so in that case we would have 0, but you want to keep all the columns, okay, intact. Okay, so if that's the case, you need to specify, okay, so for the columns you want everything. Okay, for the columns you want everything, and like that, yeah, you get the first, for instance. Okay, so that's why we're gonna get. So that's why we're gonna say, okay, here we're gonna have the indices. Okay, the indices that were filtered, and here we're gonna have all the columns. Okay, so this is going to get all the say boxes, all the filtered boxes. Okay. That is one thing. So now let's continue filtering, and now what we're gonna filter is the say, for instance, the box images, for instance. So filter box images. Okay, so box images. Box images. All right, so now remember, for the box images, we had something like that. So we had something like this. Let's just print the first 5. Yeah. Okay. So we had these paths. These are just simply paths. So now what we want to say is, look, we want to just say keep the ones that are selected. Okay, so to do that, we actually can create a loop. We can create a loop and say, okay, so what we can do is the following. We can say we want to keep all the, so we want to apply, we want to keep all the paths that appear or that are associated to the actual say indices that we filtered. Okay, so in that case we're gonna have I and have Yeah, and well, remember, because here we are going to need to create what we essentially are doing here is to create a list comprehension. We're going to create a list comprehension, and in this list comprehension we're going to do the following. We're going to create say we're going to select all the so we're going to select all the image boxes. Okay, remember, this is box images. This is box images. So we're going to select all the box images paths, that are contained in select. Okay, so for the indices that are present in the select list. Okay, great. Yeah, that's fantastic. So now we have already filtered the box images. Now let's filter the, say for instance, the box labels. Yeah, so let's filter the box labels. Box labels. Yeah, so like that. And remember, let's have a look at how box labels show up. So labels here. Remember, just numbers that are by themselves tensors. Okay, so yeah, to basically select numbers, so we just can apply easily slicing. So we can just say okay. So we can just say we're gonna have all these, but I just want you to give me the ones that are in select. Okay, so basically this is just going to print out the labels that are associated to the say desired indices. Okay, great. And this is going to filter. So this is filtering these box labels. Okay, great. So now that we understand these how to filter the box labels, let's continue. And now let's filter the, actually I think it's last, should be the last. Well, we have boxes, we have box images, we have box labels, and there's just one missing, which is these box patches. Yeah, so let's do that. So filter box patches, and let's do that, and box patches here. And let's just recall, how did the patches look like? So box patches, and I remember there was a lot of things here, like a lot of information. So just give me the first. So it's like tensor with shape 3, 64, 64 exactly. Okay, so what we want to do here is say, okay, we want to select the tensors with the shape, with this exact shape, but only the tensors that are, or only the patches, right, that are associated to the desired indices. Okay, so how do we select those? So what we do is, okay, so we get the patches and we apply the following. We apply, okay, give me the ones with the selected, but the rest, because remember there are 3 columns for each. So we're gonna have to say, okay, so give me all the columns for the, so keep the other columns intact and give all of them to me. Okay, so right, that should be fine. And all right, so that's one thing. And what is next? Oh yeah, there was something else going on, because remember that we discussed that box images and images look the same, had the same format, and yeah, that's the one that we're missing here. So we need to write this down. We need to say box, so we need to say the images, yeah. And remember that the difference between the images subkey and the box images subkey was the following: was that images included all the paths, so all the paths that corresponded to all the images within the data set. Okay, that's why they were unique. Okay, because there's one path per single image. Yeah, whilst for the box images, we saw actually that they had paths that repeated. Okay, so here we have it. You see how these, for instance, image 1 had these paths repeated 3 times, and what that meant is that in that specific image number 1, yeah, there were 3 bounded boxes. So that's why there was these paths appearing 3 times. Yeah, but yeah, let's continue. Now filtering these images. So remember, the images contain all the image paths. So what we want to do here is to actually get so what we want to do here is leverage the fact that box images contain already all the paths. But remember, in the box images, we're going to have repetitions of paths. So remember, for images they needed to be unique. So to get started, we need to get rid of the repeated paths. So how do we get rid of repeated elements within a list? So basically creating a set. Okay, so if you create a set in a Python, you are going to get rid of the repetitions. So that is the first step. Let's create a set. Yeah, and remember that right now the box images, well, it's already a list, right? It's already a list, but in case, why not? Yeah, so remember, what we did was we had a list with repeated elements. Yeah, now we converted it to a set to get rid of the repetitions, but now we want back our list. We want to work with a list, so that's why we need to actually apply again. We need to apply a list here because we want a list, and that's not all, because now we want to actually sort. We want to get our inputs, so the elements that contain that list, we want them to be sorted. Okay, so to do that in Python, we just simply say, okay, so sort these lists, sort the elements that are present in this list, right? Great. So that is all that we need for this function, yeah, to be created. And so remember, the third and last step was to return the data set, yeah, the filter data set as IMDb. So we're basically going to say step 3. So return the filtered data set. So to do that, well, essentially return and IMDb. Yeah, and that should be it. Oh, IMDb, right? So why is IMDb not okay? Yeah, because the return needs to be identity, of course. So now it's correct. Okay, fantastic. So we already defined the function that is going to filter the original data based on the input that we specify. Okay, but yeah, in the following videos we'll continue actually understanding how detection is going to work for this practical. So stay tuned. And thank you very much for your attention. I am willing to see you very soon.